Yes, I'm audible.
Am I audible, sir? Yes, sir. Yes, sir.
Yes, let me start basic introduce yourself.
Yes, sir. I am Vishnu from Shantipur, Nadia district, West Bengal. I did my secondary and higher secondary education from Shantipur Municipal High School with so 93.4% and 88% respectively. Then I completed my BSc in chemistry honors from University of Kalyani. Then I qualified in CHEM with all 126. I got admitted into that. I also qualified couple of exams. I see an at 22 and the gate last time in 54 rank. Yes, sir.
Yes, good. Next, move on chemistry topic. Yes, first of all, chemical kinetics. Yes, what the basic principle of chemical kinetics? Explain.
The chemical kinetics is the domain of the studies in which we generally studies the rate of the reactions and the rate of the reactions, how the reactions proceeds, and their characteristics about the rate. And the rate can be written as dψ by dt. So it's the extent of the reactions per unit time is called the rate to 1 by nu, 1 by v. So this is the expressions for this is the expression for
Yes. What the difference between rate of
delta is
reaction?
the extent of the reactions.
Yes, yes. Good. Next question is what the difference between rate of reaction, rate law, rate equation, and order of reaction? Explain one by one.
The rate of the reactions is defined as the extent at which the extent of the reaction per unit time is called the A, and this can be written as rate 1 by V into 1 by delta I by delta T. Now, order of the reactions, it's a rate of it's a ratio of the rate of the reactions to their concentrations, to the concentrations of the reactant. This is called the rate constant. Order of the reaction is if we write the rate law, rate law is just a law that combine that to actually combine the rate with the change of the concentrations of the reactants that are involved. So you can write K into A to the power N. So the order is called the power of the concentration term involved in the rate of the reactions. It's called the order with respect to that reactant.
Yes, what are
The power
the
of the
temperature?
term that is present at each.
Yes, good.
Yes, sir.
And what are the temperature effect on rate constant?
Your voice is not clear. Can you please repeat the question?
Yes. What are the temperature effect
Yes, sir.
on rate constant? Are you getting my
Okay, so the rate of yes, yes. So the temperature effect can be explained from the Arrhenius equations. K equals to e to the power minus EA by RT. So with the increase of the temperature, so rate of the reactions is increasing. So if we write this reaction with the temperature, we get this type of curve, sir. Exponential increase curve. This is the curve.
yes. What are the application of rate constant?
Rate constant is unique for a particular reactions that generally characterize that what is the order of the reactions we can calculate, like the first order or the second order reactions, and also the slope of the concentration versus time is totally dependent on the rate constant. So its main explications in the determinations of the order of the reactions.
Yes, order of reaction and law of thermodynamics. What the difference?
An order of reaction, law of thermodynamics.
Yes, what the difference between like zero, first, second, third order of reaction and law of thermodynamics, zero, first, second, third. What the difference? Any 1 2 point?
Sir, no, sir, I can't.
Law of thermodynamics defining the energy. Order of reaction defining the concentration. There is a difference. Yes, no.
Yes, the law of energy is related to the concentration, and time factor should be included in the order.
Yes, time, concentration.
Sir, but that is not important in the thermodynamics, sir.
Yeah, interrelation question. Yes. Next, move on collision theory. Yes. What the collision theory applications and what the interrelation between collision and Arrhenius and Wonthorf? Explain.
Yes, sir. According to the collision theory, it is that when the two molecules come close to each other, they collide with each other, and the rate of the reactions, according to the collision theory, is written as so the can be written as rate equals to e to the power minus EA by RT. So number of effective collisions, which can be from the Maxwell number of the molecules into collision frequency. Similarly, the rate constant K equals to A e to the power minus EA by RT. So this is the collision theory. We know the rate of the reactions is the number of the effective collisions. Effective collisions equals to number of the molecules that have energy greater than equals to the tension energy, that is denoted by the e to the power minus E by RT. And if you compare these two equations, you can see that e to the power minus E by RT term is there. But here is the frequency factor. So if we compare these two, the frequency factor is nothing but just the denote the collision frequency. So this is the interrelation side. Collision frequency. So the A in the RNS, and RNS is generally derived from the RNS theory is generally derived from the set band of equations. That band of isotherm, that is the set dln by dt into the into del E by RT square. So this kind of band of isotherm will be the dln equilibrium by dt into del E by. So RNS series generally can be determined from this band of isotherms.
Yes.
This answer is sufficient, sir.
Yes. Good. What the interrelation between collisions and some words used in steric factor and orientation factor? We
So
explain.
the according to the collision, yes, sir, the collision factor is that the collision factor is called the A. That is the that according to the frequency factor, it's also the collision factor within the RNS equations. And an orientation factor is that when the molecules come close to each other, this is the one of the drawback of the collision theory, is that it doesn't consider the proper orientation. Actually, the proper oriented effective collisions is not product of the proper. If we consider the two molecules like AA, AB, and the two molecules, another AB molecule is coming. So it can collide with this way or either this way. So the here you can see here the two type of here actually see two type of collisions can be
Yes.
possible factors ignored in the collision theory.
And other one is, yes, what the relation between collision theory and Arrhenius pre-exponential factor? What the formula? Relation and what?
So the A can be yeah, sir. The A equals to the collision frequency. Collision frequency. So this can be 1 by root 2 pi sigma square Ca and for the A molecules and pi sigma AB square root 8 RT by pi B. So this is the sir relevance.
Yes.
Is visible, sir?
Yes. Yes, I understand. Yeah, next is drawback of limitation of collision theory.
The main limitation is that it's only applicable for the homogeneous biomolecular reactions. It didn't consider the proper orientations of A. It's only applicable for the gaseous phase reactions, not applicable for the liquid phase reactions. And the third one will be that the collision theory really considered that during the collision, the transitional mode of vibration is transitional mode of motions is involved, but during the collisions also rotational and vibrational modes can be also possible, sir. So this is the main drawback of the
Yes, what the unit of
collision theory, sir.
Arrhenius pre-exponential factor? What the unit? Arrhenius pre-exponential factor unit.
The unit is equal the rate, sir, equals to the rate constant. The rate constant unit like liter to the power n minus 1 mole to the power 1 minus n dot second in per second. N is the order of the reaction, sir.
Yes. Yes, what is the difference? Zero, first, second, third order of reaction. Any 2-3 point differences.
So what is the difference
Zero,
between
first, second, third order of reaction.
the first difference is that sir, if you draw the concentration versus time plot, so this is the set for zero order reaction. Concentration is increases exponentially. So this is for the first order reaction. The decrease will be further slower in the second order reaction. And this is much slower in the third order reaction. So this is the circle concentration versus time. This is the part. The straight line decreases as a zero order reactions. Then the which have a greater slope is the first order that I have indicated. Then second order reaction will be a little bit more slower, and this is the third order reactions. So the rate of the different reactions is different. The third order reaction is the slowest one, and the zero order reaction, first order reaction is the fastest one.
Yes. Any limitation and drawback of order of reactions? in kinetics?
Sometimes it is found that the order can't be determined of a complex reactions if the concentrations are present in the denominator. So if you consider this reaction H2 plus Br2 is equal to 2 HBr, so the rate can be written as H2 into Br2 to the power half 3 by 2 by HBr into K plus Br. So due to the presence of the bromine in the denominator, we can't actually determine the order of the reaction, sir. So because it's a complex multi-step reaction. So this is the main drawback. So this is the an order is just an experimental quantity. So it can be fractions and the different also. Yes, sir.
Yes. A Tyson state theory. What the main application of Tyson state theory? What the relation between Tyson state theory to entropy, standard, enthalpy? What the relation?
The transition state theory actually first the correlate the drawbacks of the collisions and the Lindemann theory and first explain the A factor, that is the activation energy factor. So according to theory, that the transition state theory is that they activated complex was formed reversibly through the collisions of the molecules, and it can be formed by the A and it decomposes to the product. Now this rate can be written as Kv into T by H into e to the power del S naught dagger by R into e to the power minus del H naught by RT. And the second factor is that further del H can be written as by A plus del N naught dagger minus 1 to RT. Yeah, and del G can be written as del H minus T del S. So this is the standard equations for the transition. Yes. According to the rate of the reactions equals to the concentration of the activated species into the frequency of the vibrations of the activated species for which it decomposes to the product.
Yes.
Zero.
What the role of rate constant in activated complex theory? Yes. What the role of
Yes,
rate
if you know the order of the reaction.
theory?
Yes, sir.
What the role of rate constant in activated complex theory?
Yes, sir. The rate constant is actually denoted by the K dagger. I'm just writing KB into T by H to K dagger. So this is the so the here actually the rate constant is connected with the equilibrium constant. So the kinetics is somehow is connected to the thermodynamics. So this is the main application. So if you consider this reaction K into KBT 2 by H by K dagger, the K dagger is the sir, second dagger is the equilibrium constant for the formation of this equilibrium state. That is the that I have written. So the first equilibrium state here you can see. So using this equilibrium, we can calculate the K dagger. So this is the thermodynamics and rate constant is the kinetics. So these two factors are connected somehow through this kinetic theory. So this is the main advantage of this transition state theory, sir.
Yes, you.
But the rate constant
Yes,
is
you wrote.
here.
Yes. We wrote. K is equal to KBT upon H. Yes, no. K. Here K is a
Yes, sir.
transition coefficient. Yes, no. Transmission coefficient. Yes, no.
Yes, sir. K is the transmission coefficient, sir. K dagger.
Yes.
K is
Yes.
the sir, Boltzmann constant.
Yes. Voltage constant. Yeah. Transmission coefficient.
The K dagger is the Carnot which is the related to the thermodynamics.
Yes. So K from the quantum and classical mechanics. Yes, no.
Yes, sir.
What the relation here? Quantum and classical mechanics in K.
The quantum and classical relation between the K. Yes, sir. From the classical, if we consider, then this is called written as further like to consider e to the power del S not dagger. Yes, this is the e to the power minus del H. So you, as you can see here actually, so this is a sir, classical theory. We can calculate this one, and quantum theory is that H nu into KBT. There's a thermal energy is calculated. So H nu, that is the frequency of the activated complex, is equals to the KT Boltzmann constant. And this is the one of the assumptions of the transition state theory is that there is total 3n minus 5 number of modes of vibration present, but according to this, one mode of vibrations is different from others, which are sufficient energy, low frequency, sufficient amplitude that is equivalent to the KBT, and because of that, it decomposes into the product. And this vibration motor is converted into the transitional mode. So that's why. So this is the main application. Like H into KBT. This is the main application of the quantum. And further, the K dagger can be del G equals to del H minus del H. So that is a classical theory, sir.
Yes, good. Any drawback and limitation of activated complex theory and transition state theory?
So transition state theory, though it actually correlated the rate of the reactions with the activation energy, but it can't applicable for the sir, multi-step reactions. But that P equilibrium exists. This is only applicable for the reactant product, and only one transition state is applicable. And it didn't consider the rate of, and the main one of the drawback is that it didn't consider the presence of intermediate. It considered the intermediate is very much soft-lived and completely ignored the existence of the intermediate.
Yes, good. Yeah, next move on. The other question. What are the relation between activation energy, enthalpy of activation and temperature? For first order, second order, third order. What will be the formula? Explain.
Yes, sir. The del is equals to TD minus 2RT. So this is the fast order. Yes, a fast order reaction. So EA minus 3RT for second order reaction. EA minus 4RT. Third order reaction. And EA minus RT. This is also is for zero order reaction. So this is the sir relation.
Yes, good. What the main application of this formula in chemical kinetics?
So from this we can calculate the enthalpy of the reactions. If we know the suppose we have a reactions, we know the enthalpy of the reactions. Temperature is the known. So from that we can easily calculate because enthalpy of the reactions can easily be measured using the bomb calorimeter. Yeah.
Yes, good. The next move on. Other topic is salt effect. Yes. Simple is
Yes.
question is different type. What the relation between salt effect in ionic strength and Debye equilibrium law? Explain. What are the relations and difference?
Yes, sir. This is the sir equation that is called the primary kinetic salt effect, and this can be using the Debye limiting law. And if you finalize, this is the log K. Here has to log K0. K0 is the rate constant of an without any salt plus 1.018 Z into ZB into root I. So this is the final equation.
Yes, what the UGC here ionic strength? I. What the relation between I?
So if we yes sir, if we log this is the sir I sir 1.018 into 0.0. This is the sir equation sir that I have mentioned. Log K plus 1.018 ZA into ZB into root I. And numerical limiting law, we know the log gamma I equals to 0.509 ZA into ZB into root K. This we put this equation into we get this final equation. So this is the sir, final equation. Visible? So from this derivative and the main.
Yes.
This is log gamma plus minus.
Yes. And what the graph of salt effect in log K versus I ionic strength?
Yes, sir. This is the graph. So if we ZA ZB equals to positive, in we get positive slope, and ZA ZB is negative, you get negative slope, and the slope depend on the value. So here that 2 into 2, 1 into 1, I'm just showing sir. 2 into 2, 1 into 1. So this is the sir graph for the salt effect. So for the both the positive pieces or both the negative pieces is present, then value of the ZD into ZB will be the say, positive, and we get the positive slope. Similarly, if the value is the negative, then we get the negative slope, sir. That is the rate of the reaction is decreases if value of the ZV is negative with increase in the ion extent. This is the
Yes, what the meaning of this slope?
we can calculate the value of the log gamma plus minus from the this is the Bronsted-Jerome law, and we can tell that the primary kinetic isotope, that is the effect of the unextended rate of the reaction, that can be easily evaluated from this law, and this is called the Bronsted-Jerome laws. Yes, sir.
Yes, sir. Yes, good. And what are the effect of ionic strength? How many effect?
This is the increase of the ionic strength when the value of the Z into Z is negative, then we can rate of the reaction is decreases. But for the reactions where the value of the Z is like the both the positive, like both the reactant is positive or either negative, then the rate of the reaction is adding by adding more and salt to the reaction.
Yes, good. Yes, what the difference between slow reaction, fast reaction, and chain reaction? Yes, good graph. Yes. Yes,
The
log
fast
K2
reaction is occurred.
the fast reaction is occurred.
The fast reactions are occurred in the very much faster rate, and the rate can be determined using the formal method. So we have to go for the temperature jump experiment to verify for the and fast reactions are the example of the diffusion control reaction, the PC, and they are going through at low temperature. The reaction by the photon transfer takes then fast reaction.
Fast reaction.
They
Yes,
can be
what's the
using the
difference
pulse.
parallel reaction and conjugative reaction? What's the difference?
The parallel reactions is if I start with a particular reactant with a different product, and consecutive reactions is intermediate is present. This is the parallel reaction is the consecutive reaction. Like between the reactant and product, the one intermediate, maybe one or more than one intermediate.
Yes. Any drawback and limitation of parallel reaction and conjugative reactions?
The parallel reaction is that generally if the two products like B&C follow different orders, like one is following the first order and second one is following the second order, then the decrease in the concentration of the reactant can't be presented in a single graph. So this is the main drawback of the parallel reactions, and for the consecutive reactions, if more than one intermediate is present, the rate of the only can be dependent on the rate determining step, and others intermediate was generally neglected. So this is the main drawback of the conservative reaction.
Yes, good. And next is what the difference between steady state approximation. Yes. Difference between steady state approximation, equilibrium approximation, Lindemann theory, and Michelmanson. Any 2-3 point.
As an equilibrium is that for the equilibrium, the K2 is generally more greater than K3. So if we consider then B to C, K3, K2, and K1.
Yes, yes, carry on.
So in the steady state approximation, only we generally consider the short-lived species, and the K2, the decompositions of the intermediate is faster compared to the formations. But in the equilibrium concept, there is an equilibrium between them, and the value of the K2 is very, very greater than K3, so that an equilibrium is present. So this is that, and the equilibrium approximation, there is a rate determining state it's present, but in the steady state approximation, there is no rate determining state is present, sir. So, and also in the steady state approximation completely ignore the presence of intermediate, but the equilibrium allow to isolate the intermediate. So these are the four difference. And in the Lindemann theory, we generally follow the equilibrium approximation, and yes, sir, at the transition state theory. So this is the difference. So if we draw the curves, then we can consider. Suppose there is a curve. Yeah. So this is the potential energy curve. So the first step has a very much high activation energy. So it's a rate determining state of the equilibrium reactions, and between the reactant and product, there's lots of intermediate state is present. So this is the rate determination. This is called yeah. And here you can see there is each and every transition state. Here the more than transition state is present, and the more intermediate is present. So the steady state approximation only consider that the intermediate concentrations, the rate determining state is constant, so we can ignore the other intermediate, but equilibrium concentration can be K equilibrium in terms of equilibrium. So
Yes, good. Any relation between activation Arrhenius equation and integrated Arrhenius equation? Any difference? Any similarities? Any drawback? Any limitations? Explain. Yes.
integrated RNA equations are two. Sir, RNA equation only
Yes, yes. Carry on.
consider the activation energy is independent on the temperature, but actually in reality it is found that if the exponential factor is dependent on the temperature, then the activation energy is also the dependent. So this is the main drawback. I don't know, sir, apart from that. What is the answer, sir? This.
Yes, drawback I send you. Yes, group check. All drawback limitations.
Yes.
Finite all theories. Yes.
Yes.
Yes, good mock. Good performance from your side.